Hi and welcome to Drawing Straight Line Graphs. Just before we get going today, just want to remind you that there is a notes jotter available for this video. If you just check the description below, you'll find a download link and you can work along with me throughout the video. Okay, so the first thing we've been asked to do is on the grid to draw graphs of the following equations: x equals 8, y equals -4, x equals -2 and y equals 5. Now, before we start, I just want to think about what a coordinate actually means. You'll have used them lots in the past, and we always think the first number is about how far along, and the reason for that is we are dealing with the x-axis. The x-coordinate tells us where along that x-axis we need to be. The second value is always about up or down, and that is because it is the y-coordinate. It is where on the y-axis, going up and down, do we need to be. Now, if we are dealing with x equals 8, what we can think of are a set of coordinates. And for each of those coordinates, if x equals 8, then that means the first value is always going to be 8. Now, the y value, we can choose anything we like. We could use 0, we could use 5, we could use -3. Each of those values are now coordinates, and all we need to do is to take a point and place them on the graph where we've just said. So x, 8, 0, 8 along and 0 up, 8, 5, 8 along, 5 up, and 8, -3, that'll be 8 along and 3 down. Now, what you'll notice, hopefully, is that those 3 points all lie in a straight line. And so, we're going to draw a line that goes through all 3 points. And there we go. That is x equals 8. Now, as we come to the other equations, we're going to do exactly the same thing. Just consider coordinates at each stage. So, y equals -4. Well, again, I will pick 3 coordinates, but this time it's the y coordinate that we know at the start. We know that the y coordinate must be -4. The x coordinate this time is up to us to choose. So we could say 3 and 7 and -5. And again, all we're going to do is place a point on the graph at each of those 3 coordinates. So we have 3, -4. We have 7, -4. And we have -5, -4. Now again, you may notice that those 3 points all lie on the same straight line. So let's draw a line which joins them all together. There we go. So that is y equals -4. And we can keep going. If we look at x equals -2, that tells us that in our coordinates the first value must always be -2. But the y value is something we can choose. 6, 8, -3. And again, we can go and we can plot some coordinates in those positions. So -2, 6, -2, 8, -2, -3. And again, we have 3 points all in a straight line. So let's make a line which joins them together. There we go. And then finally, if we look at the very last one, we have y equals 5. And so that tells us that in our coordinates the y value is always 5. The x value is up to us. So let's go with 7. Let's go with 10. Let's go with -10. And so in each case, we can plot ourselves the points. So 7, 5 takes us along 7 and up 5. 10, 5 takes us along 10 and up 5. And -10, 5 takes us -10 and 5 up. And again, we get three points all in a straight line, which we can then draw all joined together. Now, you will notice that each of these lines is either horizontal or vertical. That is what these lines will always look like. If it's an x equals, it will always be a vertical line. If it is a y equals, it will always be horizontal. And the reason for that is that each of these lines are drawn through the axis. On x equals 8, it hits the axis at 8. For y equals -4, it hits the axis at -4. X equals -2, it hits the axis at -2. And for y equals 5, it hits the axis at 5. That's actually the easiest way of going about drawing any of these graphs. If it's x equals, go through the x-axis. If it's y equals, go through the y-axis. Okay, so in the next section, we're now looking at slightly different equations. We're going to use tables of values in order to draw graphs of the equations given. Y equals x plus 1, y equals 2x take away 3, and y equals -3x plus 1. Now all three of these equations are in the same format. They're all y equals, then there's some number of x and a number at the end. Now what we're going to do here is we're going to use a little bit of substitution. So we're going to be placing the values from the table, the x values, into the equation to calculate a value for y. So in the first case, we are looking at x plus 1. So if I take -3 and add 1, I get -2. If I use -2 and add 1, I get -1. -1 plus 1 is 0. 0 plus 1, 1. 1 plus 1, 2. 2 plus 1, 3. 3 plus 1, 4. Now what this has actually done is it's formed a full set of coordinates. We have 7 different points that we can mark onto our graph. So we use the table to create the coordinates that we will plot. So the first one is -3, 2. -3, -2, sorry. The second one is -2, -1. Then -1, 0. And 0, 1. And you might notice that as we're going along here, these are all forming a straight line. 1, 2. 2, 3. And 3, 4. Now, that is the starting point of these questions. It is very, very important that if you are ever asked to draw the graph of an equation, you must draw a line in as well. Now, here, what we're going to do is we're going to draw in a line which joins all of these points together, and I'm going to extend it as far as I possibly can. So there we go, a line which goes straight through each of the coordinates that we've just plotted. So then next, we'll try the next equation. Y equals 2x minus 3. So what this means is we're taking the x value and we are doubling it, so multiplying by 2, and then we're going to take 3 away. So if I use -3, 2 lots of -3 is -6, and take another 3 away is -9. If I use -2, Negative 2 times 2 is negative 4. Take away another 3 is negative 7. Negative 1 times 2 is negative 2. Take away another 3 is negative 5. 0 times 2 is 0. So take away another 3 is negative 3. 1 times 2 is 2. Take away 3 is negative 1. 2 times 2 is 4. Take away 3 is 1. And 3 times 2 is 6. Take away 3 is 3. And again, what that's allowed us to do is form a set of coordinates. So negative 3, negative 9 is our first coordinate. Negative 3, negative 9, negative 2, negative 7, negative 1, negative 5. And again, we're starting to see a straight line forming. 0, negative 3, 1, negative 1, 2, 1, and 3, and 3, 3. And again, what we want to do is now finish this off by drawing a graph, which is the line which actually connects them together. And so we're going to go through all of the points we have here in a lovely straight line going up. And then lastly, let's have a look at y equals negative 3x plus 1. So this means all of our x values we're going to multiply by negative 3, and then we will add 1 on. So we must be careful with our negative values here. We've got negative 3 times negative 3. That is 9. So 9 plus 1 is 10. Negative 2 times negative 3 is 6 plus 1 is 7. Negative 1 times negative 3 is 3 plus 1. So we've got 4. Negative 3 times 0 is 0. So plus 1 is 1. 1 times negative 3 is negative 3. Plus the 1 is negative 2. 2 times negative 3 is negative 6. So plus the 1, it's negative 5. And 3 times negative 3 is negative 9. Plus the 1 is negative 8. And again, we're going to plot each of those points onto the graph and just see what they look like. So we've got negative 3, 10. We have negative 2, 7. We have negative 1, 4. And we have 0, 1. 1, negative 2. 2, negative 5. And 3, negative 8. And again, we do have a straight line, all of those points lying perfectly in a straight line, but there is a slight difference this time in that our line is not pointing upwards from left to right, it's actually going down. And that is very, very important. The key features within these graphs are whether or not the line is going to have what is known as a positive gradient going upwards from left to right, or a negative gradient going downwards from left to right. And the key feature there is actually the number that is in front of x. If that is a positive number, it will be a positive gradient, it will go upwards. If it is a negative number, like we see in the third one, then it is going to go downwards. Now, other things to look for. Let's have a look at our table of values for y. Now, the x values have always increased by 1 every time. And if we have a look at what is happening, there is a pattern in between the numbers. So negative 2, negative 1, 0, 1, 2, 3, 4. Well, that means we've gone up by 1 every time. If we have a look at the second equation, from -9 to -7, -7 to -5, -5 to -3, -3 to -1, -1 to 1, 1 to 3, well that is 2 every time. And if we look at the last one, from 10 to 7, 7 to 4, 4 to 1, 1 to -2, -2 to -5, and -5 to -8, every single time we're actually taking away 3. How could I tell straight away that that was going to be the case? Well, let's have a look at the original equations. The original equations, we had 1x, we had 2x, we had -3x, and that matches with what the numbers went up by. Is there anything else that we could see straight away from the graph, from the equation? Well, this number at the end, +1, here it is. This number -3, here it is. This number +1, here it is. It's always in the same place. It is the y coordinate corresponding to x equals 0. And that is because of two very important features, which we'll look at in the next example. So we're now going to look at what is called the general form of these equations. It's called y equals mx+c. And the reason that is the general formula is that we have letters instead of numbers. So we have m in front of the x and we have c at the end. Now, the key phrase here, that m is the gradient of the line. Now, one way to think about the gradient is for one along, for one right, how far up. Okay, we can use that information. If we know the gradient is 3, then we can move 1 along and 3 up. If we know the gradient is 6, we can go 1 to the right and 6 up. If we know the gradient is negative, say -2, we can go 1 to the right and 2 down. We can use that value to help draw the graph. The c at the end, now it always says +c in the general formula. This could be positive, it could be negative, but what it will always be is the y-intercept of the line. Now that word intercept just means cross. So it's where the line crosses the y-axis. And so if we know that that number at the end, we can always start with a point. So let's have a go at using that. Let's go with the first equation. Y equals 3x plus 2. That is telling us the gradient. The gradient is the number in front of x, therefore the gradient is 3. It means we're going to go 1 right and 3 up. The number at the end is +2. That is the y-intercept. So this graph must begin at 0, 2. That is the first point. Now we need to use the gradient. We need to use the gradient by moving 1 to the right and 3 up. And then doing exactly the same again, 1 to the right and 3 up. Now what we've got again are 3 points in a straight line. If you want to add any more, we can do the same again, but now start thinking in the opposite direction. 1 to the left and 3 down. 1 to the left and 3 down. We can keep going with that until we've got all of the graph filled, but that is going to be enough. You can actually draw a straight line graph from simply 2 points if you're feeling confident enough. So we will just draw a line which joins each of those points together and also continues as far as we can across the graph. If we try the next equation, we'll do this one in red. So it's -2x plus 6. So we'll start with the +6. If it has a +6 at the end, Well, that means that the y-intercept is 6. It means it must cross the y-axis at 6. If we now go to the gradient suggests -2, meaning for every 1 to the right, we go down 2 spaces. So 1 to the right, down 2. We continue. 1 to the right, 2 down. 1 to the right, 2 down. We've hopefully got enough points here in order to draw it. But again, if you want to add any more points, just keep following the pattern. 1 to the right and 2 down. So this line is going to go through the 0, 6. It's going to go through the other points that we've just plotted, and it's going to keep going down and down and down. And there is our next line. In the third example, we have x minus 5. Now for this one, again, we have that intercept. We have an intercept of -5. So the first thing we can say here is that this line is definitely going to cross the y-axis at -5. But now the gradient, we don't actually have a value in front of x. Now the reason we don't have a value in front of x is because that value is 1. Usually when we're talking about algebra, we don't use the number 1, we just use a single letter to represent that. But that means in this case the gradient is 1. And so what that is saying is, for every 1 to the right, we're going to move up 1. So 1 right, 1 up. 1 right, 1 up. 1 right, 1 up. And we can keep going with as many points as we think we need in order to draw that line. But that should be enough again. And let's draw the line in, going through each of those coordinates that we plotted. And our final one, let's have a look at our final equation. It is y equals 2x. Now for this one, we are looking here at the very end and we don't see a value at the end. So it would suggest that there is no intercept, but what it actually means is we could call that plus 0. It means that our line is actually going to cross the y-axis at 0. So 0, 0 will be the first point on our graph. Now the gradient, the value in front of x is 2. So we're going to go 1 to the right and 2 up. We're going to go 1 to the right and 2 up. 1 to the right and 2 up. And we can keep going again with that if we really want to, but we should have enough points marked in order to do that. So let's join up our points with a straight line and going straight through the points that we have drawn. Okay, and so finally we come to the exam question. This came from Edexcel in November 2017 and it was on Foundation Paper 3. So this is actually a calculator paper, so we could use calculator if we felt we needed to at any point during this question. So it says complete the table of values for y equals a half x take away 1. So again, in this situation, we have got y equals mx plus c, so we could use the version that we've just been using in the previous example, but the question has specifically asked us to form a table of values, so that's what we should be doing. Now what this means is each of our x values is going to be multiplied by a half, and then we will subtract 1. Now I would suggest, if you were using a calculator for this one, that wherever you are substituting values in, use brackets. Okay, so we could type in a half brackets take away 1, And then all you need to do on your calculator is keep replacing the number inside of this bracket with the different values in your table. And so if you did that, a half, and you put -1 in there, a half of -1 is negative a half. So take away 1 is -1 and a half. If we put 0 into that bracket, it will be a half times 0, which is 0. Take away 1 is -1. If we put the value 1 into that bracket, a half of 1 is a half. Take away 1 is negative a half. The next one's already been done for us, it's 2, 0. And then finally, if I put 3 into that bracket, a half of 3 is 1 and a half. Take away 1 is a half. Now, as we're going through here, we should just be checking, does it match with what we've looked at in the previous questions? Well, let's have a look. The value in front of x is a half. If I look at each of these values, it is going up by a half every time, so that is a good sign. The other part, -1, that should be our value for the y-intercept. It should be the value at 0, and it is. Therefore, I can be pretty confident that my answers are now correct within that table. It does also suggest, as the second part of the question, that we should then draw the graph. And so that's what we're going to do. We're going to take each of the points that we've just calculated and place a point on the graph. So this is -2, -2. It is -1, -1 and a half. So that's going to be halfway in between the -1 and -2. We're going to have 0, -1. We're going to have 1, negative a half. We're going to have 2, 0. And we're going to have 3, a half. And all we need to do, it does ask for the graph, which means we must draw a line which joins through those points. So we take a line and draw it all the way through. And also just make sure, I'm just going to have to extend my line a little bit longer because we do want to make that graph go as far as we possibly can on the grid. And so we've done everything that we've looked at so far. There is only one extra element to this question, and that is use your graph to find the value of x when y equals 0.3. Now what that means is we need to actually read a value from the graph. And so what we need to do first is find this value of y equals 0.3. Now what that means is going up the y-axis until we are at 0.3, which is there. And we're going to draw a line along until we hit the line that we've drawn. That is then read down with a straight line to the x-axis. Now for me, my answer is suggesting that x equals 2.5. Now yours may well be slightly different because you can probably be a little bit more accurate than I have on the screen here. But 2.5 is roughly the answer to that question.